Hello everyone, welcome back to our adventures. In today's video, we will solve the VM1 challenge from MalwareTechBlog's series of challenges. It is basically a reversing series of challenges intended for beginners in the field of reverse engineering. So let's start the VM1 challenge. I have already downloaded the zip and extracted it, and inside of this we get two files, the ram.bin and VM1. This VM1 file has a .exe extension at the end. So first, let's take a look at the ram.bin file. I'll just look it with the hex viewer. So it is just a bunch of bytes which doesn't really make sense at the moment. And the second file, which is actually a 32-bit PE file, Windows binary. So let us open it with IDA VM1 file. And this binary doesn't have a main, it just starts with the start function itself. So let's try to reverse it. First, it basically does some MD5 initialization stuff, which is not really useful at the moment, but we might need to get back to it later. Then it calls two functions, get process heap and heap alloc. This can also be done with the help of malloc function, but this is just the Windows way of allocating memory. And whatever the return of heap alloc is stored here in this global variable. So let us just rename it to something like memory pointer. After that, we can see that it does a mem copy into the memory pointer, whatever this data is, and this is the size. So let us display this as decimal, and we can see that it is 507. And we also saw that ram.bin has the same size, 507 byte. So it is safe to assume, and we might check it later, that this is basically the ram.bin, whatever the contents of ram.bin is in this data blob. And this is some random looking data which we saw in the ram.bin file as well. Then after that, after we have mem copied it into the memory pointer, which is a global variable, we call this function. So let's go inside this. And this is not too large. Let's reverse this as well. So basically here it moves into some local variable 0. So let me just rename it to I. And then here it moves into ex1 and it checks if ex is 0. And this doesn't really make sense because we just moved ex to 1. And if it is 0, then it jumps at the end. So this jump will never happen. So it will always go into this large block. So what does this block do? Let's see. So first of all, it just moves I into ECX, and into EDX we move the mem pointer in which it has the random looking data. Then we move from EDX plus ECX plus hexFF into EX. So basically EDX has mem pointer, ECX has I, and then this is some offset hexFF. So in this line, what is happening is it just gets some from memory pointer of I plus hexFF. This is what is happening here. This is what is happening in this line. We move into EAX whatever is at memory pointer at offset I plus hexFF, and we store it here, whatever that byte is. We store EX here. So let me rename it to byte 1. Then we get I into CL, we add 1 and store it back. So this basically means we are doing an I++ here. Then what do we do? We see the same pattern here. Again, we move I, we move the memory pointer here, and then we grab the memory pointer of I plus XFF, which is I plus 1 because we have incremented it here. So this is the same as here, just that I is I plus 1 here. So this, we can call this as byte 2. Then again we see the same pattern. We move I into DL, we add 1 and then write it back. So again an I plus plus. And so again the same pattern, we just grab the next byte. So what this basically does is it grabs the first byte from the memory pointer, then the second byte, then the third byte, and this will be byte 3. Then what do? We again increment I by 1, and then this function is called with byte 1, byte 2, and byte 3 as its argument. As we can see, they are pushed in that order. We move the byte 1 into EX, then we push it, byte 2 into EDX, push it, byte 3 into EX, push it. So this function will take 3 bytes. And let's go into this function. And this is the main VM loop. So basically a virtual machine is, let's say, a obfuscation or a protection technique in x86 assembly. For example, the instruction push, for example, we know that push means that it will take a register, and whatever the value that register is holding, it will push it into the stack. But in a virtual machine based obfuscation, what we do is we define our own opcodes. Like for example, for opcode 1, let's say, we will say that it will move some data from somewhere, then it will XOR to registers and store it somewhere back. So it is basically just a mapping of instructions. Like for example, opcode 1 will do this, opcode 2 will do this. That is a virtual machine based obfuscation or protection technique. So let's see what is happening here. So first of all, let me just rename this as well. Byte 1. I'm just basically fixing the signature of the function. Byte 2, byte 3. Now what we can see here is we take the byte 1 which was passed into this function into EAX and store it here, and then we compare it with 1. Let me just call it opcode for now. So it checks if the opcode is 1. If it is 1, then what does it do? It takes the memory pointer, which is a global variable again, and get the byte 2 and add to it. So basically we are doing here is a pointer of byte 2. This is what is happening here. ECX will hold this, and at that memory pointer plus byte 2 we store byte 3. Here this is happening because ECX holds the memory pointer plus byte 2, and at DL we do move the byte 3. So basically we are doing memory pointer byte 2. So this is just a write where in ECX we have some memory location, and in DL we have a byte, and we are just moving it there. So this is a great point to start writing our tooling for this. So let me open the Rust file. Because I'm learning Rust, I'll do it in Rust. So I defined a main function. Then we need to import this fs for reading the file, and then we loaded the ram.bin. Why? Because the byte code, the memory pointer we have this, which is basically just a ram.bin, the contents of ram.bin. So I'll just read the whole file into a vector, which is a vector is just a list in Python. So I loaded the whole file in the file contents vector. Then I have created 3 U8s. U8s is just a byte unsigned char, and we created the 3 bytes that we saw, and at some temp variable which we might need later. And then I will perform a loop for I in 0 to the length of the vector, and step by 3 because as we saw in the previous function that we were incrementing I 3 times, once, twice, and here thrice. That's why I have to do a step by 3. And then we saw that whatever byte 1 is, it is just a file contents of I here, I plus xff. Then byte 2 was I plus 1 plus xff, and byte 3 was I plus 2 plus xff. Whatever we saw here, we just wrote it into Rust code. And then inside of this function, this is the VM loop, let's say. So inside of the VM loop, we saw that whatever opcode, which is just basically byte 1, we compare it with 1. So there is such thing as match in Rust, which is basically a switch statement in C. So we can use, instead of if else, we can just use match, and we can provide some conditions inside that if byte 1 is this, then do this, which I just defined here. Like for example, this, like I matched byte 1 with 1. If it is 1, then what do? We take the memory pointer, which is file contents, and at byte 2 we store the byte 3. Similar that we saw here, we just grab the memory pointer of byte 2, this file contents of byte 2, and at that we store byte 3. So I just wrote whatever we saw in the assembly. Let's move on to the second function. Then we compare here. Then we compare if the opcode is 2. So if it is 2, it will jump here, and at 2, what does it do? It grabs the memory pointer of byte 2, basically the same thing, and we dereference it. In the opcode 1, we were writing to it. In this, what we are doing, we are reading from it, which basically means mem pointer of byte 2. We did this here. We are just reading from it and storing it in some global variable, some byte. So we can just save, rename this as temp, let's say, and that's what the temp I defined here is for. So we can also add this in the match statement as well, because we know what the opcode 2 means. So I have done that. So for byte 2, we actually byte 1, if it is 2, then we say that temp equals to file contents of byte 2. And moving on next, then we see that there is compare with on opcode 3. So if it is 3, then what do? This is some complex operation. So what do? We move into etx temp, which we just assigned. Then we move into ex memory pointer, and we do memory pointer plus byte 2. So basically here, memory pointer of byte 2, and it is in edx, I believe. Ex, yeah, ex is holding memory pointer of 2, and then we dereference it, basically, which means ecx is equal to a byte from memory pointer of byte 2, and then we XOR ecx and temp. This is memory pointer of a temp. So basically we just XOR memory pointer of byte 2 and temp, and then we just store it back into memory pointer of byte 2. So which basically means that the whole opcode that it is doing is this thing. This opcode 3 is just memory pointer of byte 2 XOR equal to 10. The whole block just means this in C. So we will add this in our match statement as well. So basically I did this, the same thing. The file contents of byte 2 is XOR equal to, this is XOR equal to 10. And because this is a switch in Rust, we have to handle all of the cases. For handling all of the cases, we can just give an underscore here, because this VM is just consists of 3 opcodes, 1, 2, and 3. And for cases other than that, it will just jump back. It will just compare 1, 2 here, and 3. And if it is neither of this, it will just jump to the end and just return. So we have to handle that case as well. So if it is not 1, not 2, and not 3, then we will just break out of this loop. So this is our whole script. Now what we want to know is whatever we XORed, what is the contents of it. So let us just print that as well. I will just do print and file contents, basically this thing. We just need to print it, whatever this holds after the operations are done. So we have written a script, then we need to compile it with rust c nodes.rs, and let's run the nodes.exe file. And yeah, because this is just an integer, we need to print this as a character. So I will just cast it as a character, as char. Now let's compile it again and run it. yeah, we get the flags are VMs are for malware, and this is actually the correct flag for this challenge. So in this challenge, we just saw a very simple implementation of a virtual machine based protection, which only consists of three opcodes, 1, 2, and 3. In real life scenarios, you will get like hundreds of opcodes or thousands of opcodes, but this was just a beginner challenge. That's why it has only three opcodes. So that's all for the video. Thank you for watching. Keep hacking and stay awesome.